Alright, so we got diamonds. That's one suit in a deck of cards. And then the other red cards have this symbol right here. Right? So those are the hearts. So you got your diamonds and you got your hearts. Okay? And then the black cards, you have this kind of design like this, goes up. I can't really draw too good. Looks better if I colored in. This is called spades. And you have this kind here, which in cards, this is called clubs. Some people call it clovers because it kind of looks like that, but in card talk, it's clubs. Alright, so then every suit, this is a suit, S-U-I-T, like a suit of clothes. Every suit has the following cards in it, right? You have your ace. Let me find an ace to show you. Right. So this is your ace of spades, right? So it's going to have an A on it, but the ace is like your number one, right? It's like the number one. In most card games, it's a number one. And then you have the numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then you have a jack. Right? So the guy with the J, that's your jack. And then you have the queen, right? So it's going to look like that with the Q. That's the queen. And then finally you have the king. These cards right here are referred to as face cards, right? Which makes sense because they all have a face on them. They're the only cards that have people with a face. So you have ace through king of diamonds, ace through king of hearts, ace through king of spades, ace through king of clubs. So notice this is your 10 numbers plus your 3 face cards. So that's a total of 13 in each suit, right? So each suit has 13 cards. And the whole deck, a standard deck of cards has 52 cards in it. When you talk about a standard deck of cards, you don't count jokers. The jokers, that's like extra on the side. Alright, so why are we talking about what's in cards? Because there's a lot of problems that talk about pulling a card and what card, or what's the chance of getting a certain card, right? So I can have a deck of cards like this. I can say, what's the probability if I choose a card? Right, we're going to do different probabilities. So what's the probability that I'll choose a red card? Alright, well think about this. Which ones are red? The diamonds, right? And the hearts. Right? So 13 and another 13, right? It's 26 red cards, 52 cards altogether. If you simplify that by 26, 26 divided by 26 is 1, 52 divided by 26 is 2, right? Since half the cards are red, the probability that you might pick a red card is 1 out of 2. So if somebody wanted to do a bet with you and said, hey, let's play a game, I'll bet you. I bet you won't pick a red card. You pick a card, and if it's red, you win, and if it's not red, I win. Would that be a fair game to play? Yeah, it would be fair. You might win, you might not, but you have an even chance to win or not win. Right? Okay. But what if it was the probability that you would pick hearts? So how many hearts are in the deck? It's 13, right? All these cards. And how many is in the deck total? 52. So you do 13 divided by 13, 52 divided by 13, 13 divided by 13 is 1, 52 divided by 13 is 4. Doesn't that make sense? If there's 4 kinds of cards, 1/4 of them are hearts, you have a 1 in 4 chance of picking a heart. So now if somebody wanted to play a game and say, hey, guess what, I'll bet you $1. If you pick a heart, you win my $1, and if you don't pick a heart, I'll win your $1. Would you want to play that game? No, that would be foolish, right? Because you only have a 1 in 4 chance of winning that game. That would not be a fair game to play. Choosing a red, that's fair. Half is red, half is black. Choosing a heart, that's not fair. That doesn't have the same probability. All right. So now we get into questions about replacing versus not replacing. All right. So what if I wanted to know the probability that I'm going to pick a heart on my first try, then I'm going to pick another heart. So I'm going to do 2 picks. So come in here, and what's the chance that on my first pick I come in here and I grab a heart? Well, that's 13 out of 52, or 1/4, right? But now what's the chance that I'm going to pick a heart on my next turn? If I picked a heart out of here, that heart's gone now. So now there's only 12 hearts left. And now there's only 51 cards in the deck. So after I pick one out, that changes my numbers. I don't have 12 hearts anymore. I don't have 13 hearts anymore. I only have 12 hearts. And I don't have 52 cards in the deck. Now I only have 51. And so I already know 13 over 52 simplifies to 1/4. 12 over 51. And I'm going to, when I do 2 picks, I multiply them together. And I say multiplying fractions, that's no problem. Top times top, 1 times 12 is 12. Bottom times bottom, 4 times 51. 204. Now I know this is going to simplify because they're both evens. But I don't really want to simplify these big numbers. So let me show you how your calculator simplifies for you. If you don't have a calculator, go grab one so you can work with me. My fraction is 12 divided by 204. So I'm going to do 12 divided by 204. Convert that into decimal form. Then I'm going to ask my fraction to take this decimal and turn it back into a fraction. And when it turns into a fraction, it's going to turn into a simplest form fraction. So I'm going to press Math. Very top choice is fraction. So enter, enter. 1/17. So remember, on our calculator, we press the Math button. So if somebody wanted to bet you if you could pick 2 hearts in a row, you surely don't want to bet that. You only have a 1 out of 17 chance of winning. Right? Those are not very good odds. You want to play games where your chance of winning is even. All right. So now I could change my story a little bit. What if I want to say, what's the probability that I pick a heart, replace it, and then pick another heart? All right, so the probability that I'm going to pick a heart in the first place, right, we know that's 13 out of 52, which we can simplify to 1/4. So now, if I pick a heart, so I come in here and I pick a heart, right, but then I put it back in the stack. So now what's my chances of picking a heart again? Isn't it still 13 because there's still 13 hearts in there because I put it back in? And now there's still 52 cards in the deck because I put it back in. I replaced it. And 13 over 52 we know is 1/4. Multiplying fractions, that's no problem. Top times top. Bottom times bottom. You have a better chance of getting 2 hearts if you put the card back in than if you don't. Alright, is that making sense to you guys? So there's a difference between if you pick something and don't put it back, or if you replace it. Alright, now we want to look at another scenario. We're done with cards. Let's spin a spinning wheel. Have you ever been like to the carnival and you spin a wheel, and depending on what you spin, you win a prize? Alright, you don't have to worry about drawing this wheel. Alright, here's the way this game works. You come to the carnival and you spin the wheel. If you land on green, you get a little prize. And if you land on pink, you get a medium prize. And if you land on yellow, you get a big prize. Do you see why that would make sense to do it that way for the carnival? What does the carnival want to give away most of? Little prizes, right? So you got a lot of little prizes, couple of medium prizes, and just one big prize. So let's look at this. What's the probability that you would get a big prize when you spin the wheel? So that's going to be the yellow one. Alright, so you go spin your wheel. There's only one space with a yellow, right? How many spaces we have altogether? 8 spaces, right? You have a 1 in 8 chance of winning. So theoretically, if you played the game 8 times, you would win a big prize. Right? Because 1 time out of 8, you would probably land on yellow. Probably. Now you could get lucky and land on yellow every time, if you're lucky. But according to math, you would only land on the yellow 1 out of 8 times. Alright, so what's the probability that you would spin the wheel and get the big prize, and then you spin it again and you get another big prize? So I wonder what the probability is that you'll spin the wheel twice and win 2 big prizes. You think that's going to happen very often? The carnival would probably go out of business, right? So the probability that you spin and get a big prize would be 1 out of 8. Now, you spun the wheel, and now it's over. And now you're going to spin it again. So does your first spin have anything to do with your second spin? No, that's what we call an independent event. You spun it, it's done, it's over with, now you're doing a new spin. Your probability of getting a big one this time is 1 out of 8. So the probability that you're going to get a big prize, and then again you're going to get another big prize, you multiply these 2 probabilities together. Multiplying fractions, that's no problem. Top times top. Bottom times bottom. 8 times 8, 64. You only have a 1 out of 64 chance of getting 2 big prizes back to back. Alright, I wonder what your chances are of getting 2 little prizes. So what's the probability that you will get 2 little prizes? So the 2 little prizes are going to be the green ones. So you have to take it one at a time, right? So on your first spin, what's the probability that you'll get a little prize? 1, 2, 3, 4, 5. That's 5 out of 8. You spin the wheel. You landed on your green. Now it's done. Now you're going to go spin the wheel again. So that's a whole new probability. And again, you'll have 5 out of 8. Multiplying fractions, that's no problem. Top times top, 25. Bottom times bottom, 64. Ooh. It's a pretty good chance that you're going to spin that wheel 2 times and walk away with 2 small prizes. Do you see how the carnival people stay in business? Right? Because you want that big prize, so you're going to keep paying your dollar and keep trying to spin to get the big prize, but you don't have too good of a chance of getting that big prize. Alright, so we're going to stop for now.